OptiCarVis. Improving automated vehicle functionality visualizations using Bayesian optimization to enhance user experience. OptiCarVis optimizes visualization designs intended to improve trust and perceived safety of automated vehicles. Based on user feedback, it iteratively adjusts design to improve users' subjective perceptions of the ride. These visualizations include highlights of other road users and automation functionality status. Although automated vehicles can autonomously perform driving tasks, users need to trust them and feel safe to accept the technology. Previous work found that visualizing internal automation functionalities according to the functional hierarchy of automated driving significantly improves trust and perceived safety. However, every user is unique, with diverse preferences, abilities, and needs, which means that automated vehicles are perceived differently. As a result, a one-size-fits-all approach to visualization design to calibrate trust and perceived safety is insufficient. We parameterize the visualization design. These parameters included the transparency for semantic segmentation, the trajectory of other vehicles, the ego trajectory, the CAD-covered area, occluded cars, and the vehicle status. Additionally, the size for key elements such as pedestrian intention, the ego trajectory, and the CAD-covered area. Designing the visualizations aims to enhance various subjective metrics like high safety and trust, and low cognitive load in understanding them, which can conflict. The design parameters form a design space, with each combination representing a specific visualization. Users' subjective ratings can be represented by an objective function that maps a design to specific rating values. We treat the visualization design as a black box optimization problem, aiming to find the visualization from a set of designs that maximize the objective function. However, finding this for each user is challenging, as the relationship between parameters and user feedback is difficult to model. To address this, we introduce OptiCarVis, a human-in-the-loop optimization approach. The optimizer starts by selecting parameter values, like semantic segmentation transparency, from the design space. The user experiences this design during the ride. The user ratings are then used as objective function values, such as perceived safety and trust. By modeling the function, f, using each iteration's feedback, the optimizer can predict the impact of adjustments and find optimal designs in just a few iterations. We conducted an experiment to explore our approach. We investigated the impact of the human-in-the-loop optimization on users' subjective ratings. Moreover, we aimed to find out which optimization approach is the most effective, comparing cold start with warm start initialization approaches. Lastly, we compared the optimization with traditional design approaches. Our study with 117 participants started with an introduction to the automated vehicle and the visualizations. Then, participants were assigned one of the 6 groups. In the baseline condition, they experienced the 3-minute ride without visualizations. The route was the same for the other conditions. In the custom design condition, participants experienced a ride using an average design crafted by 8 automotive UI experts recruited beforehand. In the other custom design condition, they individually created a custom design, which was shown afterward during the ride. In the cold start optimization, the optimizer initially selected random parameters for the first 5 iterations to sample users' individual ratings across the design space. Participants experienced the latest design in each iteration and provided subjective ratings, which the optimizer then used to estimate new parameter values for the next iteration. In the warm start optimization, we leveraged the average design by the experts to initialize the optimizer. This provides ratings of designs to skip the sampling phase directly starting the optimization iterations. In these iterations, the participant experienced the ride with the latest design, provides their rating, and received new parameter values based on this. In the other warm start condition, the users could first create a design themselves, which the optimizer used to skip the sampling. Afterward, the participant experienced the ride with the latest design, provides their rating, and received new parameter values based on this. The study found that the human-in-the-loop optimization significantly enhanced perceived safety, predictability, trust, usefulness, and satisfaction in visualizing automated vehicles' functionalities, compared to participants' custom designs and expert-defined designs. For further details, please see our paper.